Here we are at example 6 from our 4.4 set of notes. We're asked to solve this by factoring. And we notice that right away, actually everything is on one side, so that's great. And we got 0 on the other. Now we're going to first, again, look at our GCF. Can we pull anything out right away there? And it looks like they actually all share a common x squared. Believe it or not, it doesn't have to necessarily be a number because we can't pull out a common number. But because they all have x squared, we can pull that out. And that does act as our GCF. So we have x squared times the leftover stuff, 4x squared, plus our 12x plus 9 equals 0. And now we're going to go ahead and create these two binomials for that trinomial right there. So we're going to factor that down. We have, it looks like we have 4 and 9 as our A and C value. So 4 times 9, we have 36. Our B value here is 12. So we're going to create our list for 36. So we have 1 and 36. We have 2 and 18. We have 3 and 12. We have 4 and 9. And 6 and 6. And then we have to ask ourselves, which pair combined to give us that 12 that we need in the middle? Well, it looks like 6 and 6 accomplished that. So we're going to go ahead and use that. 6 and 6. Now again, we're breaking down our 12 in the middle into 6x and our 6x. Because we have a positive 12x there, both of these guys need to be positive. Now we'll go ahead and drop down our 4x squared and our positive 9. And we have our equals 0 on the right side still. Factor by grouping says that we can go ahead and split this down the middle. Now looking at the first pair, we notice that we can pull a 2x out of both of those. And when we do that, we're left with a 2x plus 3. When we look at the second pair, we notice that we can pull a 3 out, just a normal positive 3. And when we do that, we're left with 2x plus 3 as well, equals 0 on the right side. They both share that common factor of 2x plus 3, so we'll pull that out. And when we pull that 2x plus 3 out of both of them, we're left with this leftover 2x plus 3 equals 0. Zero product property says that we can go ahead and split this up and set each one equal to 0. So we have 2x plus 3 equals 0 and 2x plus 3 equals 0. And now we're going to go ahead and solve for each one. So we'll subtract 3 from both sides. Get 2x equals negative 3. Divide both sides by 2. And get x equals negative 3 halves. Now, it would be the exact same on the other one because you're still working through the same process. But notice how we end up with the exact same solution. All right, so we have x equals negative 3 halves and x equals negative 3 halves. Believe it or not, though, and this is a common trap, this is where some students actually, they just circle those two answers and say, hey, I'm done. And when they do that, unfortunately, that's wrong. I mean, they've done a lot of the work, but it's easy to forget something, especially that happened in the beginning, okay? Notice how we divided this by, or factored out that GCF by x squared. It is common, and I'm going to star this, guys, okay? If you're taking notes, star this part. It is common where students earlier will divide this x squared over on both sides and kind of cancel that as like a GCF. That is wrong, okay? Don't accidentally do that because it is actually a wrong answer when you try and do that move, okay? The reason why is earlier it was example 3 right here. You can divide a number on both sides and get rid of it. You can do a number. When it comes to a variable, like x squared, you have to also use zero product property there, okay? So when it comes to a variable, you're also solving for when that's equal to 0. The reason why you're doing that is if this is equal to 0, well, 0 times this whole part right here is equal to 0, one big 0, and that is still equal to 0. So this x squared counts as other solutions. So don't forget that, okay? It's common where students, because they kind of pulled it out as a GCF, they kind of negate it as a potential answer. Don't accidentally fall for that trap. It's common, okay? Then, to solve this, all you would do is pretty much take the square root on both sides, or just see, hey, x is 0. Now, because it's x squared like that, you're actually going to have 2 of those. Okay? And those are our other 2 solutions. X equals 0, another x equals 0. We have x equals negative 3 halves, and x equals negative 3 halves again. Some teachers are pretty relaxed on like what the final answer is on this part. So what I mean by that is if you had like x equals 0 and then x equals negative 3 over 2, some teachers are good with that. They'll take that. However, if it were me, I would play it safe and pretty much circle or square what I've done. Okay, because if you do that, you are guaranteed to get it right. Okay. Honors Algebra 2, they'll talk about this thing. It's called a multiplicity of 2. It pretty much just means you have the exact same answer twice, as you can kind of see here and here. Okay, they will definitely talk about that. All right, but just don't fall for that trap where I went and starred that x squared. Okay, don't fall for that. But again, though, that is example 6 from our 4.4 set of notes.